Hi everybody, welcome to another training video concerning the Moose framework. In this training video I'm going to explain you a new add-on that is we have modeled zone classes within the framework. So there are different zones that can be defined using those classes, and it allows you to actually test the object proximity or the object presence within those zones, consisting out of groups or units or statics. The zone classes are derived from base. There's a zone base made that actually implements the core functions for zones, and then from that there are two classes derived: a zone based out of a radius, a circle around a certain point, or a polygon zone, which allows to implement more complicated forms, concave or convex polygons. The radius zone, there are two subclasses implemented in that class. The first one is a zone that implements the zone object within the mission editor, and the next one is a zone around a moving unit, so that zone will be movable as the unit moves around. Groups, units, and other classes in the future. I'm thinking also on sets that were defined within the framework. They will be able to use those zone classes and test the proximity or the presence within the zone's parameters. The zone declaration, how do you use the zones? How do you develop using those classes? Well, you declare, for example, a radius zone like this. So you need to have a point vec2. A point vec2 is basically a 2D pointer with an x and a y coordinate. It's a table. The second one you need is a radius. So you declare like zone underscore radius dot, and then the constructor of this class is new. Then you need to define a zone name, which will be everywhere. In each zone class you need to provide this, which provides you an additional name, a name that of your choice, what the zone, to reference the zone within the mission. For example, when you send a message to a user saying you have arrived in that zone, and you can use this zone name to reflect that automatically. The point vec2 as a second parameter, and then the radius. And having done this, then you'll have defined a zone object within radius zone. The zone as defined within the mission editor, the zone class, is very simple. You just provide the name of the zone as with the name as was defined within the mission editor. Yeah. A zone unit, so as I said, you can use a unit that defines the center of the zone with a certain radius around that unit. So first, in this small example, we are looking up the unit by unit.find by name, then unit name. Remember, the unit class find by name will use the database class or the database object within Moose to actually retrieve the unit wrapper class. Then a radius, so you can then instantiate a zone unit by using the new constructor, giving the zone name, the unit as was retrieved here, and the radius, a number as you want, which is expressed in meters, by the way. Group polygon, this is a more complicated zone already. So here what you need to do is you need to define within the mission editor a group, and the waypoints of the group will define the polygon that defines the zone. So you need to provide a group instance to the zone polygon constructor here. Yeah, very simple. All right. Then how do you validate whether objects or units or any other class is within the parameters of the zone? Well, the group class actually implements three functions, and these functions is completely in the zone, and you provide there the zone object, which can be any zone type or any zone class that you have declared within your mission. is partly in zone, meaning some of the units can be in the zone and others not, and is not in the zone, well, meaning there is no unit of that group within that zone. Okay. As a reminder, just to be clear, the zone object can be a zone radius, a zone unit, or a zone polygon object. So it really doesn't matter which zone you are testing for. Okay. Unit, same thing actually, but there you only have two functions because a unit is one object. Yeah, so it's either within the zone or it's not in the zone. Very simple. You can also use the zone object itself to validate the presence, but then not of an object. You need to do an indirect test because the zone object will actually accept a point, actually a table of an X and Y coordinate. So what you need to do is, for example, here I'm testing unit, so I'm searching for the unit. I'm retrieving the point fact2 and the point fact3 of that unit, and then I can use these two functions here of the zone object to test the presence if that unit is within the zone. So is point fact2 in zone, and gives that accepts a point fact2, and is point fact3 in zone, that accepts a point fact3. These two functions here are polymorphic, meaning that any zone object will have these functions available and will work. So there's some other nice APIs that are within the zone definitions. For a zone radius and derived zone classes, you can flare a zone, you can smoke a zone, you can get the point vec2 or the point fact3 of the zone with a specific height, because remember, zone radius is a surface, so you need to provide a height and you get back a point fact3. You can retrieve the radius, or you can retrieve a random point fact2 on the surface within that zone. You can set the point, the new reference point of that zone, and you can set the radius as well of those zones. Flare zone is also available in a zone polygon object, and smoke zone as well. So in a few minutes in the demos it will become really clear what we mean with those flare and smoke functions. How do you use and how do you retrieve the documentation of these zone classes? Well, I've listed them very nicely for you here. So you can have the class APIs descriptions on the Moose GitHub pages here. So here they are listed. And you can see here zones. When you click on this, you have the list of the zones available, and you can then click here on zone unit, and you have the API descriptions of unit. You can go click what does a point fact2 do here. It's this, you see. So it's very clear, very easy to retrieve the documentation. And there's a lot of work being spent in documenting all of this. I hope you appreciate it. There's some online training videos available on the YouTube channel. Well, I'm currently making this one here right now, but basically you can find the training videos on the YouTube pages. Each of these classes have example test missions, and for your convenience, in the next few minutes in this video I'm going to go through these demos, these example test missions, because an example tells 1,000 words. So I'm going to explain you as usual the source code, and then a short view on how this is working in the mission. So here we are in the Eclipse development environment that I've set up for this demo. Let's go to those test missions here, and you'll see here 3 directories: test zone polygon, test zone radius, test zone unit. These are the directories where you can find a mission to be executed in DCS and a Lua file that explains the source code, how this was developed. Okay, so forget this. This is an error. Not a problem. Okay, so basically, let's kick off with the demos. So I'm having here a source code where I'm having a group inside group that's going to drive around. I'm defining a zone, and then I'm doing a scheduled action where I'm going to drive while that group is driving through the zone. If it is in the zone completely, then it will send a message to every user every second, and it will smoke red while driving through that zone. The zone itself, when it is being declared, it will also smoke a white smoke around the zone parameters, and it will be 90 points smoked. This is very useful if you set up a zone and you want to see how that zone is within your executing mission. Then use this function here. So this is the test mission setup. The current test mission for zone, as I explained, is very simple. I've defined a trigger zone within the mission editor, and then I have a unit named test inside Polygon that's going to drive around the parameters of the zone and is smoking red when the group is driving inside the zone. It's smoking nothing when it's outside the zone. The zone itself will also smoke a white smoke around the parameters of the zone. Now let's have a look how that works. So now the mission is running, and as you can see, this zone that was defined is surrounded by white smoke, and you see the tank driving its route, crossing the parameters of the zone, and while it is driving around, it is smoking inside the zone with a red smoke. And it's really nice, as you can see, doing the exercise very well. And just remember, when you look at the simplicity of the source code, it really doesn't take a lot of coding to do this. Yeah? This is what Moose is about. So here you go. So the next demonstration of a test mission is the test radius test mission. For this one, there is not a zone defined within the mission, but there is a static object that's being defined with the name house. I'm retrieving the 2D coordinates of the house within the mission using getPointFact2, and then I am defining around this object a 300 meter radius. And again, this tank is going to drive around the zone as in the other test mission. So for completeness, the source code of how this is written. So group inside is the tank that's driving around the parameters of the zone. The static is retrieved using the database object with the name house. Yeah, so house will contain the static object. The zone radius is being declared. The constructor takes 3 parameters: the name of the zone, the point fact2, which I'm retrieving, so I'm doing house double point get point fact2, it gives me back an array with an x and y coordinate, and a 300 meter parameter. I'm smoking the zone again white with a 90 points around the zone. Every second I'm sending a message. The scheduler says every second. The message will be displayed 1 second, and the group with the function is completely in the zone. Zone A is testing, am I driving in the zone? Yes or no, and if yes, I'm smoking a red flare. Now this is very interesting that I want to show you. That is that this function and this function looks exactly the same. Although the zone is different, zone A, the actual code that you are using to test a different zone is exactly the same. And this is the power of polymorphism. Alright, let's have a look how this works. Same thing really, but now you can see that in the middle there's this bunker, a static object. Around the static object there's a 300 meter parameter that defines the zone. And as you can see, the tank is following the exact same route around the zone. Yeah, so I think this is clear enough. You can try this out later. Yeah. Now up to something more interesting. As you can see here, I have defined a tank, which is a unit, actually transport, that's driving 20 kilometers per hour from here to there. I'm having the tank, the test inside Polygon, that's driving around the tank. The tank, or the reference unit, has defined a zone that's 100 meters around the perimeter of that unit. So once that tank is driving within 100 meters within the unit, it will smoke red, and when it's outside, it will smoke nothing. The actual reference unit is flaring every 5 seconds around the parameters of that unit, 90 flares into the air. Now, before we go into the discussion, let me quickly grab the source code of this demonstration. It looks very similar to the previous, but with the difference that you need a unit with the name tank. Then you provide that unit as a parameter to the zone unit constructor, which takes 3 parameters: the name of the zone, the unit, and the parameter within meters, the radius within meters around that tank. If the tank moves, the zone will move. Here it's a bit more complicated to actually simulate the presence of and the coloring of the zone. So I'm not just measuring the tank position and checking whether it is completely within the zone or not, but I'm also coloring the zone around the tank every 5 seconds, flaring 90 flares in a white color. Let's have a look how that works. Right, so here I am. As you can see, the flares are going into the air, and the tank, the reference unit, is progressing. The tank is entering the zone while the reference unit is progressing to its target waypoint, and it's coloring a red smoke when it is in the zone. You can see clearly that the zone is moving. I'm going to speed this up a bit. Yeah, this is very interesting within missions, so you can really play with this. Do note that you can change the radius around the reference unit with one of those more interesting APIs with the set radius function. Yeah? Okay. The fourth test demonstration mission is the zone polygon test. Here I have defined a group with the name Polygon A that has a couple of waypoints, and that defines the polygon. Note that the polygon in this case is actually a trapeze. Yeah. So here you really will only see a red smoke when the tank is driving through the parameters of the zone, when it is entering the first triangle here and the second triangle there. The outside is all around here. Okay. Let me quickly show you how this was coded. Let me retrieve very quickly the Lua file here. Here you go. So I am retrieving the group, which I'm naming group polygon here using this line. And then I'm instantiating a zone polygon using the constructor new, giving the polygon name, it's a free name as you can choose, and the group that defines the polygon using its waypoints. Again, I'm smoking it white, and I am testing the presence of the group within the zone. And this code looks exactly the same, although the polygon is completely different from a form perspective. Okay, so here you see the trapeze being smoked within the mission, and once the tank is driving through the parameters, it is actually smoking red. There you go. Looks nice, isn't it? You can really make very complex polygon forms. So you can really play with this test mission and change the form and see what happens within your mission. Thank you very much. So I hope you found and you find this implementation interesting for use within your missions. If you have questions, you can reach me on Skype with the ID flightcontrol_Skype. Or you can join the slack.com site. There's a development community there, which is growing by using this reference here. And I hope to see you next time in another add-on. And just for your information, the zone classes currently defined are only surface types, but I do have plans to add into the class hierarchy as well volumetric zone types, as well as more complicated zone types. For example, a surface polygon not defined by waypoints, but defined by units within a group or units within two different groups. Yeah, so we'll see how this progresses in the future. Thank you. Bye-bye.